Hi everyone. Today we're going to take another look at the surface area of composite objects. Our objects will become a little more complicated in today's lesson, but the same principles apply as our last lesson. So to begin, I've written down a few useful formulas, all of which you have seen before. So you have the area of a triangle, 1/2 the base times the height. You have the area of a rectangle, the base times the height. You have the area of a circle, which is pi r squared. And then you have the area, or the surface area, I should say, of a cylinder, which is 2 pi r squared. I'll break it down for you. 2 pi r squared. That's kind of like two of these, 2 pi r squared. So literally how you say it. Representing the two circles, the top circle and the bottom circle. And then finally you have the 2 pi RH added on, and that's the kind of outside of the cylinder, if you will, this kind of surface here that I'm shading. Okay, that being said, that's everything we need to know to complete a lot of these problems. So I guess we'll just do a few examples for a refresher. Okay, so first example. We have a cylinder sitting atop of a rectangular prism. So we want to find the surface area of this particular composite object. Okay, an object composing two separate shapes, if you will. Okay, so for this, we'll just take the approach of figuring out the surface area of the rectangular prism first and foremost. So surface area is equal to, this is 8 by 6, and that's going to happen once, twice in the back there, and then on the top and on the bottom. So that's 8 times 6 times 4. And then finally you have 6 by 6, and that happens on the right side and the left side here. So we have plus 6 by 6 by 2. Okay, so that's the start of this, so let's just calculate that to have that number ready to go. 8 times 6 times 4 plus 36 times 2. So our surface area is equal to 264 centimeters squared. So this represents our rectangular prism. Next up, we'll calculate the surface area of the cylinder. So the cylinder surface area is equal to 2 pi r squared plus 2 pi RH. Now since the radius is 2 centimeters, we'll plug that value in, 2 pi times 2 squared plus 2 pi multiplied by 2 multiplied by the height, which is 7. So we have 2 squared is 4, times 2 is 8, so we have 8 times pi plus 2 times 7 is 14, 14 times 2 is 28, so you have plus 28 pi. Altogether, this is 36 pi. So that's the cylinder altogether. Now, what we have to keep in mind when we do surface area of any composite object is that this space here that I'm shading in, we need to account for that because that's not actually on the surface. These two objects are attached, and so the bottom of the cylinder does not actually show. It also covers up a space on the rectangular prism equal to that of the area of that bottom circle. So we have to do some accounting here or some omission. Sometimes we just call this the overlap. So where there's overlap, we actually have to subtract. So the overlap is here, and it is the area of one of those circles. So the overlap is the area of just this circle here, but it happens twice. We have to subtract it from the bottom of the cylinder, but we also have to subtract it from the top of the rectangular prism. So what we end up subtracting is 2 multiplied by the pi r squared. So we're going to end up subtracting 2 multiplied by the pi r squared. 2 squared is 4, 4 times 2 is 8. So we have 8 pi that we need to subtract. And that's kind of why I left this like so, because what I'm going to end up doing is combining all of these together, and that will be my total surface area. This will count for a positive, this will count for a positive, and this will count for a negative. So just to kind of keep track of everything, that's what I like to do. So all together, let's just kind of put everything together. The total surface area, is equal to 264 centimeters squared plus 36 pi minus 8 pi. So we have 264 centimeters squared plus 28 pi. You may have seen as we were going through this, you have 8 pi plus 28 pi minus 8 pi. So those two just cancel, and you're left with the 28 pi. And now finally, I'll actually just kind of figure this out. 28 pi, add it to 264, just so you can see. You get around 351.96. So this is usually how I claim my surface area. So surface area is equal to all of this. That boils down to here. And then that equaled out to be 351.96459443 centimeters squared. And so what we'll do for all of our practice is round to the nearest whole number. And that will be my answer, 352 centimeters squared. Okay, so that's our first example. We'll take a look at one more. So in this example, we have a cube, has a dimension of 4 by 4 by 4, and it's hard to see here. However, what I'm trying to convey is that there's a hole drilled into the cube. This hole resembles a cylinder, and it goes all the way through the cube. So this is kind of empty space. So on the inside of the cube, there's essentially more surface showing that is equivalent to what part of the cylinder? Well, if we think of this as the cylinder here, we essentially have this much more what's shaded here, we have that much more surface area on the inside of the cube. And then what's in white here is actually kind of omitted. That is surface no longer showing, because if it were a solid cube, it would be showing, but since you drill through it, that circle is now gone on both sides. So thinking about how you're going to kind of put together all the different parts of the surface area in positive and negative ways is something that you should do before you even start the question. That being said, I think I'm pretty sure about what I want to do here. I hope it makes sense, and if it doesn't, just follow along, and I especially hope that it makes sense by the end of this. Okay, so surface area. Let's do the cube first. And that's going to be kind of simple. There are 6 sides and they're all the same. So it's 6 multiplied by 4 by 4. 4 by 4 gives me that face. And then there are 6 of them. So that is, I believe, 96. 4 by 4 by 6. Yep, 96 centimeters squared. So that's the surface area of the cube. Next we'll do the cylinder, and I'm gonna just do the part that I know is added here. Or actually, let's do the whole formula and then we'll kind of break it down from there. Okay, so the whole area should be 2 pi r squared plus 2 pi rh. So 2 pi times 1 squared plus 2 pi times 1. And then the height is going to be this kind of length of the cylinder, if you will. And we'll put that in as 4 centimeters as it spans the whole cube. Then we'll evaluate all this. So 1 squared is just 1. So we have 2 pi multiplied by 1 plus this boils down to be 8 pi. Okay. So that's the surface area of the cylinder. Now all together, we're going to have to add some things up. However, this right here represents the area of the 2 circles. And that's actually something we have to take away. So we're going to end up having 96 centimeters squared plus 8 pi subtract 2 pi. And so that's going to be 96 centimeters squared. So this is the total surface area. 96 centimeters squared plus 6 pi. We'll very quickly calculate that. So plus 96, we have roughly the surface area is equal to 114.849 and 3 fives, then 9 centimeters squared. We'll just round that, like I said previously, to the nearest whole number. So it's going to be 115 centimeters squared. Okay, so that would be our answer here, and that should be everything you need to know about composite objects involving cylinders.